Hello everyone, welcome to the lecture 2 of our series Introduction to Labview. Today's topic will be the data types in Labview, the basic data types in Labview. Basically, you all have heard about the data types and you know about the data types, the basic data types that in various programming language. The basic data types will be like numeric first. Second, the Boolean, the true and false, whether the signal is coming or not, and the massive signals. So the third is string. So we see that how these data types available in Labview and what are their, since our Labview is a color coded language, what is the color code for these data types, how we can implement these data types in our projects. So let's get started. I think in the last series, in the last lecture, I've already told you about the basic environment of the Labview. So first we start with the numeric data types. Numeric data types, for that you can have a control available in a control palette. This is our numeric control. Let's take a numeric control, and with that numeric control, I got a icon at in the block diagram. So this is our numeric data types, and you see the color of the icon is orange. That means the numeric data types color is orange. But in numeric data types, we have 4 type of representation in Labview. For example, this is the default representation, which is known as the double precision point, and double precision means it is a floating point kind of data type. And if you want to see that how many kind of representation available in a numeric in a numeric data types, then you just right click on the icon and go to the representation. Now these all are the all our representation. The first representation will it is categorized into a 4 part. For example, first is the precision, like floating points. Then second is integers, signed integers, then unsigned integers, and then complex number. So the complex number and the floating point has a similar kind of color if you categorize by the color. And if you want to categorize by the representations, then it is 4 kinds. So let's just start it. For example, let's just say that I just added a number with our floating point data type. Let's take a 2 number. It is like change it input. Input A and input B. Okay, then this is our representation, that is input A and input B. Let's just increase the size, and let's take an indicator, that is the output. Okay, so now suppose I just run this program, and if whatever I add, like I can add 4.8 here and 5.6 here, and I can get a value in terms of the decimal digits. So this is what we have, a floating point kind of data type, where I can have a decimal number itself. I think you already know what are the floating points. Then suppose, for example, I just change the output representation into like a signed integer. Let's take a I32. Signed integers have like signed and unsigned integers itself are categorized into 4 parts, like quad, long, word, and byte. It is like if you want to say that how much represent how much the range of the numbers, it represents that that what kind of representation we are having. Like for example, the basic formula for that for this kind of data types is available. Suppose let's write down. I open some value and I will write down on that what should be the value, what should be the representation formula for that. It is like 2 to the power n minus 1 to, let us say, minus 2 to the power n minus 1 to positive 2 to the power n minus 1 minus 1. So this is for the sign integer. Okay. So if you have like n is equals to, if n is equals to 8, then this value will become minus 128 to 127. Okay. Similarly, this is for the of course this is for the sign integers, and for unsigned integers, for the unsigned integer, this value will become for unsigned integers, this value will become from 0 to the power n. I think we all have that concept in our digital electronics, the same similar concept. So if we have a n is equals to, if n is equals to 8, then it is from 0 to 56. Okay, so let's just see that how it will work. You see, I got the 10.4, 4.8 plus 5.6 is what? It should be like 10.4. Then, but since I have changed the representation of the output, it becomes 10. Now, suppose it is like I'll change to 5.8. Now 5.8 to plus 5.6 is something 11.4, and what should be our value? It should be 11. It will get 11. So 11.4 will get 11, and if I having 5.8 to 5.8, what should be it? It should be 12. Like 5.8 plus 5.8, it means 11.6. Now you see 11.4 will become the 11, and 11.6 become 12. So it is a round off. Now we have to very much curious about like how the middle value will go, like 12.5. So suppose I'll just add 0 with the 12.5, then how it will work? Let's just take, it will become 12, but similar kind of thing, if I change to 13.5, it becomes 14, not the 13. You see, whenever we have the middle value like 13.5 and 11.5 and 9.5, it will move towards the nearest even value, not the odd value. So 13.5 will not get 13, it will go at 14. But if you change it to the 14.5, then it will obviously get 14. Similarly, if I got 15.5, then the nearest even value will be 16. So we got 16. So I think you got the point. So this is what we have when I change some the output into an integer format. Now let's think about something else. Let's take another values. suppose this is a floating point. Let's just take sign integers. Okay, so let's change the size to 4 that you can have. Now we have input B. Let's say input B. Input B2. Let's just say B2. And it is input A2, and we have. Now I'll change the representation of all these inputs. Let's take its I16. Let's take it representation to I16 and just add these number, and you see there's a dot came, the red dot in all the value in the previous one also and in this one also. What does it represent? It represents the change, the manipulation of the data. Like for example, I take our input in a I16 format, but the output is in a I32 format. Similarly, in the previous one, I have a input in a debial format and the output in a integer format. So there is a change in the data types, that not the data types, let's just say the change in the representation of the data type. And that quotient dot, it is known as the quotient dot. Quotient dot represents the manipulation of the data. You can find out with using a quotient dot, there is a change in the data, some kind of conversion is have done in that point, so it represents the data conversion kind of thing. So it is our output. Let's say for example, I'll just open it, and since it is 16 I16, then its value is far better than, let's just change to 8. The output will change to I8, not the I32. It will represent you something. Okay, so I'll just add 128 to, let's just say 2. Now 128 itself is not in a I8 format. So what I got minus 128. Now you all think that how it's possible. Basically what happened in our Labview, that suppose the series of the I8 will be from like minus 128, then minus 127, and then it will go about like 0, then 1, and up to like 127. Okay, now whenever you add anything to 127, suppose I add plus 1, now it should be 128, but since the range is only from minus 128 to 127, what happened, it will goes back to here. So it is kind of a circular addition, which we have seen in Labview during when we have a different kind of representation in a numeric. So what it goes like 128, like 127 plus 1, it will comes minus 128. Similarly, if I add 8, it will become minus 121. Suppose if I add 127 to 127 itself, it becomes minus 2. Okay, and then when I add like 128 plus 128 plus 128, it becomes 0. So the whole circle will be completed. So it will come at the 0 point. Similarly, in the negative side also, minus 128, if I add like minus 1, then it should be minus 129, but it will cannot be 129, it will go to the 127. So it is a circular addition kind of thing in our integer. Similarly, if we have this is a signed integer, let's have an unsigned integer. Okay, for unsigned integers, let's change these representations to what we can have. Let's change it to representation, the output representation to U8. Okay, now let's say that if I add 128 to 1, then what happens? Since its value has been, it's again minus 127. I think I have, okay, because it does not have 128, right? So it is minus 127 again. Then if I have 128 to 128, and it's become 0. So I think I have give you the wrong sign. It is from 0 to the power n minus 1. So let's just have, if I change this value to U16, like let's change it representation to unsigned value, U8, change it to U8. And plus 1, it is 1. So it is 2 power n minus 1 minus 1 again. Let's say 127 plus 1 again. Oh, sorry. I'm confused. It is B3, input B3, and it is input B4, and the output is here. Sorry. That's I'm thinking about it. So it is like 128 to 128. Let's just say that what happened to it is 0, and if it is 128 plus 127, so it is 255. So the range will not 2 n minus 1, it should be 2 to power n and minus 1. The value is this. Okay, so it is from 0 to 250, so it will complete 256 numbers. So this is a unsigned format. Okay, so again the value is like that. If I add 127 to 128, it will become 0 again. And if I change to 129, then it will again start from 1. So this is a similar kind of addition. Now if I change this to, let's take the last representation of this is complex number. Now I have to, this is the complex number, and for the complex number you can have like, you can see that it will change the value representation with the imaginary number. Let's take a CDB, that is a complex double precision, and it is also a complex double precision. You can see the representation has been changed drastically. Since we have I value also, let's take I change 2 as I, so it will change the value to 2I. So this is how you can have a different kind of data types. Now depending upon that, you have different functions also, like if you want to change from like complex integer like into a polar format, into a real, you want to segregate the real and the complex value also, you can do that also. So these are the different kind of things you can have with the different kind of data types. So this is numeric data types that I already told you everything, like addition, and what is the circular addition, what is the, if you want to change the from one representation to another representation, this is a numeric data type. Its application is available. Obviously, if you like in the upcoming lectures, we see there's many application where we don't need a floating point, we need a simple integer value. In that case, you can have just an integer representation, does not require a overall. So let's start with the new representation, that is a Boolean. Now let's take a Boolean. So this is a different kind of Boolean, like having, now similar in like in numeric, suppose we have these kind of representation. So Boolean is what, like 0 and 1, 0 and 1. So if the signal is available or not, so it is like on and off kind of situation. But in Boolean also, if you guys heard about in a digital electronics, there is a simple word we have like a latch. So as compared to the numeric data types where we have so many representation, in Boolean, we only have two kinds of like you can say the representation, or you can say the mechanical action, because it is the Boolean is kind of a mechanical action, on and off, and other is it's kind of switch, and other is a latch. Now what is the latch? Latch are the devices, if you have in a digital electronics, these are the devices which can store a 1 bit of data, and it is used to create a flip-flops obviously, and these are the very important devices in digital electronics. Similar kind of available in our Labview. For example, if we have a switch, this is a switch. You can say that it is a switch. Then we have latch. Now this is a latch. Okay, so we have a switch and we have a latch. You can have both change from here also. I'll just show you. You can just add and you can go to the mechanical action. Similar, here we get a mechanical action. We have a switch and we have a latch. Now in switch also we have switch when pressed, switch when released, switch until release. These are different kind of things available. Now first let's take what is the difference between a switch and a latch. Now switch is something which will let's talk about the change in the states. Now the Boolean has only two states, 0 and 1. Now suppose here my Boolean function, or sorry, the Boolean control is on a off mode. Now it will not go to the on mode until and unless I provide some action on that. For example, let's say your fan switch. Now your fan switch, if you on the fan, okay, now you press the button and it will give some energy, or you can say electricity to the fan, and it will start moving. Now suppose it will not stop moving until and unless you again press the switch. So this is the action of the switch. You need to you need the external source or the user to change the state of the switch. Until it will not change its state by itself. Now the latch are different. Latch are something you provide a mechanical action, obviously you press the latch, but when all the program, all the operation has been done, the latch will come to its default state. So every latch has some kind of memory. Okay, here also the latch has a memory, its default state. Now default state is mostly is in a false state, but you can change that also. But right now we just see that how we can change, we can have a switch and a latch in different kind. Now suppose we have that switch. Now I'll just use LED here. It is something output. Okay. It is so too big. Okay. This size is fine. So I'll just connected it. Now let's just say when I press it, I'll just press it. Okay. And it has changed the state. I'll just press it and it changed the state. Now I'll change it to the mechanical action switch when release. Now if I run it, when I press it, it will not change the state. You see, it will only change the state when I press, when I release the button on that switch only. Now if I release the button and it has changed the state. Similar, it will not change the state. It will only change the state when I press on it, release on it. Okay, so this is a different kind of switch. So we have three kinds of for each switch and latch, like switch when pressed, switch when released, and there is a third kind, switch until release. You see that you think about it is kind of a latch, but it is not a latch, it is a switch. Consider it as a doorbell. Now doorbell, if you press it, it will give some sound, and when you release it, it will not. So it is kind of that thing. So when I press it, until and unless I pressed it, it will in a on a state. When I remove it, it will on a off state. So this is, that is switch until I release. So this is a switch. Then change it to the, if I change it to the latch, let's take the latch. Sorry. Okay, this is a latch. Now latch are different. Suppose I on it. Let's say I run it. Where they go? Okay, I run it and I will change the value to, it will not change because I think representation is different. It is latch when pressed. Okay, now I'll change this value. Now if I run it, you see it will on, but it will again go to the default state. Now if I change this value to here, let's take the mechanical action, switch when pressed. Okay, it will remain on until and unless I make it again in a off state. So you got the difference between a latch and a switch. So move to next part. You see the application of latch in the upcoming lecture. The next is the string. Now string are very, like, they are the message signal. You got here the control. This is the string control, and we got the indicator, wait indicator. This is a string indicator. So we can just say the command and the message. Now strings are very important when you prepare for the CLAD. When you go for the CLAD preparations, there are so many functions available for the in the string format. So let's just change the size. Okay, suppose I'll just say that India is a great country. Okay, and I run it, I got the same message. Now here also we have a different kind of representation, but it is available here in the control, in the front panel, not in the block diagram. So we have a normal display which is available, but then we have a code display. Code display means it is a coded kind of things. For example, if you want a space, it is /s. The representation will be like that. Suppose I just enter in a different format. I'm proud to be born okay, so you see if I change the line, it is /n. So this is kind of thing. Now there is a password display also. For example, if you are creating an ATM machine or something like password protected alarming system, in that case you can have a input as a password display. Then we have a hex display also. So but basically most of the time we mostly use a normal display. So this is a string. I think this kind of things is you can understand that how we have a different kind of data types available in a Labview, and how we can, in that data types also there are different kinds of representation, and each representations have their own application. When you go for the bigger picture, you can see that each data types have the bigger applications. Okay, so thank you so much.